Hello friends, welcome to my channel. In today's video, we'll cover one classic machine learning project for housing dataset. So in this video, we'll cover all the steps related to data cleaning, data manipulation, data evaluation, and data analysis. And also we'll cover model building and library understanding. So without any further discussion, let's get started. Step we are importing and understanding the data. We are importing libraries and also we will import the data. In this project, I am importing NumPy, Pandas, Seaborn, and Matplotlib warnings and Math library. Let's explain all these libraries in detail. So for Pandas I am using for data manipulation and analysis. Pandas provides data frame objects to handle tabular data efficiently. I'm using NumPy, which is used for numerical computing. It provides support for large multi-dimensional arrays and matrices along with the mathematical functions. Okay, you can do addition, subtraction, and so many complex calculation very easily. I'm using Seaborn and Matplotlib for data visualization. Seaborn offers a high-level interface for drawing statistical graphs, and Matplotlib provides more fine-grained control over plots. I'm using warnings because which is used to suppress warnings during data analysis, ensuring a clean output. Because otherwise it will give so many warnings which are really very unnecessary. I'm using math, although it is not utilized in this script because the math library is commonly used for mathematical operation. But I'm importing it I was not sure whether I'll use it or not. Okay, so in first step, I'm importing libraries and data, and which will we understand the data very well. I'm using warnings, pandas, numpy, seaborn, matplotlib, and math library. Okay, pandas is used for data manipulation and analysis, which provides data frame objects to handle tabular data very efficiently. And I'm using NumPy, which is used for numerical computing. It provides a support for large multidimensional arrays and matrices, along with mathematical functions. I'm using Seaborn and Matplotlib for data visualization. Seaborn offers a high-level interface for drawing statistical graphics, and Matplotlib provides more fine-grained control over plots. Using warnings, which is used to suppress warnings during data analysis, otherwise it will give you lots of unnecessary warnings. So basically warnings will ensure you with clear output, and math is used for mathematical operations. Okay, let's run this code. It is run successfully. I am importing the data by using pandas libraries. I am also using head function to look like how to check how our data will look like. You can see here I am using very small size of data because the main purpose of this video is to understand model building process and model evaluation process. So I am not explaining more EDA and analysis part. So you can check the values, how price will be our target variable, and other variables we will use as independent variables. Okay, so I hope till this point it is clear. Let's check the shape. Always make habit to check your data very effectively. Okay, because it will give you the idea how to build a model. Okay, let's check like whether we have null values or not. Although I am using clean data, we have to check these things for each and every data. Okay, because null values will fluctuate your result. So I'm using clean data, so we don't have null values. Now the second step is data preparation. So data preparation is very important part because our model will not use categorical or other variable like a categorical or any other things which is not numerical. So we have to make sure like our all the columns have numerical values which we will fit to our model. So we can see here we have the binary values for this particular columns. So let's reconfirm it. I'm adding more row. Now saying I want to check it for main row. Value counts. Okay, this is binary. Okay, let's check it for guest room also. Okay, it is also binary. Let's check it for basement. Okay, it is also binary. Let's check it for others. Okay, so all these columns has binary values. So I have already created a list for this so that I can use functions. It will apply to each column in one go. So it will remove the unnecessary coding. So always make habit to use functions because it will help you to reuse your code. Let's run this. I am using binary map function. It is defined to map categorical variables with binary values. It is used to convert yes or no values into 1 or 0, which is good for our model and which is suitable for our analysis. And by applying it to original data, it will apply the binary map function to specified columns. Let's recheck our data. Always make habit to recheck the values the function which you have applied, because sometimes it may be possible it is not run successfully to your data. Now we'll move to the third step, which is dummy variable. You can see here other columns are numerical, but furnishing status have still categorical values. So let's check how many values it is having. Value counts. Okay, we have three different values for furnishing status column. So we have to create three columns. Okay, let's create dummy values. I am using get dummies to create dummy variable for categorical columns. And for this I am using pandas, which will be used to convert categorical variable furnishing status into dummy or indicator variables. It will convert categorical data into numerical format, which will be allowing in machine learning algorithms. So that we are using get dummies. Let's check it. You can see here. I hope you are aware about the how dummies are created. So let's explain me very fast. If this particular column has three values, so it will create three columns basically. So you can check here if it is furnished here. So it will write 1 in furnished, and for remaining 2 it will be writing 0. and for this semi-furnished, it will write 0 in other two columns and 1 in semi-furnished. So basically here in our data, 0 0 will correspond to furnished, 0 1 will correspond to unfurnished, 1 0 will correspond to semi-furnished. So why I am not using 1 0 0 for furnished? Because we require two columns only, because it is self-explanatory. If this will with these two columns will have 0, it means that it is furnished. It automatically leads to the 1 over here. So we don't need all three columns, we will drop any one. Okay, so here I'm dropping the first one. I'm using get dummies again to drop it, and then concat this result with original data. Okay, so for this I have used dummies. I have created new data set, so I have to compile it with the original data set. So for that I am using concat. Okay, so basically concat function is used to concatenate the original data frame with the dummy variables, and then the original column furnishing status will be dropped to avoid multicollinearity. Okay, so here I am dropping the first one. You can check here. Now we have all numerical columns. So let's check the info. I'm using info to check the values. So all the data type is in numerical. Now we will move to the step 4, which is splitting the data into training and testing sets. I'm using scikit-learn, which is used to split the data into training and testing. It allows the model. This allows for model training on one subset and evaluation on other subset. Okay. So for splitting our data, I'm using sklearn.model selection, and from this I am importing train and train test split. So I'm splitting my data in train and test one. I'm using 70-30 ratio. You can use as per your problem and your data. Because I'm using small size data, I'm using a 70-30 ratio. You can use 80-20 or 75-25. Let's run this code. Okay, it's run successfully. Let's rescale the features. Why I'm using rescaling the feature? Because our data are not scaled. You can see here in our original data, the values are very far from each. So we have used describe function somewhere. Okay, let me check. Okay, I have not used it. Let me show you. Housing.describe. You can see here our original data will look like this. The minimum price of area, minimum value of area is 1650, and the maximum is 16,200. Here it is 1 to 6, 1 to 4, 1 to 4, and so on. Here it is 0 to 1 and so on. Because these are binary, it will not create much impact. But for numerical variables, we have to scale it. Otherwise, it is not standard for each columns and particular columns too. Okay, so here I'm using min-max scalar. You can use standard scalar. Depends like whether you have outlier present with your data or not. So from sklearn.preprocessing, I am using min-max scalar. Let me check it. Okay, I have not fitted it, so let me create a list for this. For price, area, bedrooms, bathrooms, stories, and for parking we have to create. Other columns are binary, so we don't need any scaling. So let me run it. Here I am using fit transform, otherwise it will not fit it to the data. Okay, let's check it. You can see here now all the values are look normal. Otherwise it was it was in thousand somewhere, it was in lakhs somewhere, or it is in just one number. I hope till this point it is clear. Let's move to the next step, which is divide into x and y sets for the model building. Why x and y sets are important? Because y sets are dedicated to target variables. You are fetching your target column to the new data, and you are dropping your target column from x train data. And one more important thing, let me explain it. Why I am not using min-max scalar before model building, like before splitting, because I don't want to introduce to the new data, to the testing data. Okay, so you can see here, this is my y train and this is my x train. Now let's move to the next step, which is building a model. I'm using linear models. I'm using recursive feature elimination method to eliminate unnecessary features. See, basically here I'm using small data. I'm telling it again and again because this your real life data will not look like this. It will be very dirty data. You have to do lots of data cleaning, data analysis, and you cannot select the features directly because you have to do lots of analysis to select particular feature. I'm using RFA because it will use certain methods, some statistical methods, and remove unnecessary features automatically. So from sklearn I'm importing RFA and also linear regression and I'm using n features as 10 because I have very less number of feature. Otherwise, see, if you have multiple features like more than 100, more than 1000, so you can select like top 25, top 30, top 50. It will completely depend on your data size and your problem. I'm using it as a 10 to show you more like how your model will be built and how you will have to remove the unnecessary features. Okay, here I am checking which are the 10 features which will be selected to the model building. Area, bedrooms, bathrooms, storage, main road, guest room, basement, hot water, heating, and so on. Okay, so let's apply to the training data. I'm building model using state models for the detailed statistics. You can see this is the summary of our model. In context of linear regression model, the concept of R-squared values and p-values are very important for understanding the model's goodness of fit and significance of individual predictors. As we have already seen, which are the variables we are using for further model building process. These are the variables, and R squared is a statistical measure that represents the proportion of the variance in the dependent variable, which is our target variable. So which is explained by the independent variables in the regression models. I hope you are aware about linear regression model, how the line will look like and how other independent variables will affect the dependent variables. Okay, So generally this r square value should be the ranges will be between from 0 to 1. Okay, so r square is equal to 0 indicates that the model does not explain any of the variance in the target variable, meaning that is a your model is very poor fit. And if your r square value is equal to 1 indicates that the model perfectly explain all the variance in the target variable. Generally it is not possible because your model is not perfect all the time, so it should be near by between 80 to 1. 0.80 to 1, it's fine. It completely depends on your problem statement. Okay, so I hope now you are clear about r squared values. So see, in our cases it is 0.6669. It means that 67% of the variance in the dependent variable is explained by the independent variables in the model. Okay, so your target variable means your price values are 67% will be explained by your independent variable. Okay, it is not enough because it does not provide information about the quality of the prediction, so it should be used in conjunction with other evaluation metrics. So we'll move to the next summary, which is our p values. So generally we can consider like p values are associated with each predictor variable which are independent variables. So you can see here the values are different in every variable. Okay, so they indicate the statistical significance of each predictor's contribution to explaining the variance in the dependent variable. Null hypothesis for each predictor is that it has no effect on the dependent variable. Okay, I hope you are aware about hypothesis. P-values tells you the probability of observing a relationship between the predictor, which is our price, and the response variable is extreme as the one computed from the data, assuming the null hypothesis is true. Okay, so I hope you are aware like if the small value if value of p is small, so the model will be better. Okay, it suggests that there is a strong evidence against the null hypothesis. It indicates that the predictor variable is likely contributing significantly to the model. Okay, if a large p value suggests that there is not enough evidence to reject the null hypothesis. Okay, I hope now it's clear to you. Okay, so let's move to the our model building process. You can see every value is lesser than 0.5. Okay, in bedroom it is, I think it is 0.07. So it should be between 0.05. So let's remove it from our model. So in this step I am dropping bedrooms and rebuild our model without this column. Again I am importing model, adding constant, which is very important aspect. You can see the summary. Again you have to consider r square value, t values and p values. You can see the coefficient will look like this. This is the standard error. This will be your t values, and again you can see now your model is perfectly good, but again you can improve the r square values. So let's check the summary after dropping constant. Okay, so now you can see here the p values will be p values are good, so we'll check by using VIF. Okay, that is variance inflation factors. So generally we can consider the lesser value of variance VIF lesser than 5 is good. Okay, so let's check it. Let me show you the code for it. I'm using new trained value, new data after dropping a bedrooms column. I'm rounding off the value of VIF by 2, shorting it in ascending so that I can evaluate it easily. So now this is also fine. So let's check residual analysis of the training data. So we are moving to the analysis evaluation step. Let's check whether it is normally distributed or not. So by using this graph, we can check our error are normally distributed or not. So here you can see it is completely fine. Error are normally distributed. If it is not distributed normally, then you have to reconsider your model. Okay, you have to pre-train and retrain your model. So now your model is ready for prediction, so we can apply it on testing data. So these are the final variables which we are using for further evaluation. Okay, now it's time to apply scaling to your testing data. So whatever we have done previously model building, you have to do it again. Okay, now you are dividing the data into X test and Y test. So I'm popping price to Y test. I'm dropping variable from X test. This is for model prediction. Now it's time to evaluate your data. Let's visually check it to compare it with the actual values. Okay, perfectly fine. Your model is perfectly fine, and not perfectly fine, but you can consider it for further evaluation. Okay. So in this video I am not focusing on the accuracy and to perfectly build a model. This was just to show you how you can explain your model and how you can build a model perfectly, and you have to reconsider or add some features to get higher accuracy. You have to drop certain features to get the good accurate result, but in real time it is completely different. You will have really very bad data. Sometimes you have to put lots of efforts on data cleaning part and analysis part. So I hope now it's clear to you and you are aware about how to build a model. So in this tutorial we have covered the entire process of building a regression model for predicting housing prices. We have explored data, pre-processing, feature selection, model building and evaluation. So I hope it will be helpful to you. So don't forget to like, share and subscribe for more tutorials. Thank you for watching and we'll see you in the next video. Bye.